Hello, welcome to the CCNA preparation guide brought to you by Eduonix. This is for the exam 200-120 and this is chapter 5. We're going to be taking a look at some IP routing technologies. We're going to be taking a look at Dhcp on iOS routers, describe the features, types and applications of ACLs, configuring and verifying ACLs in a network environment, identify the basic operation of NAT, configure and verify NAT, configure and verify an NTP as a client, recognize high availability FHRP, configure and verify syslog, and describe SNMP v3 and v2. So, what is Dhcp? Well, computers use dynamic host configuration protocol to request Internet Protocol parameters from a network server such as an IP address. The protocol operates based on the client-server model, and as of about 2010-2011, most modern networks ranging in size from home networks to large campus networks and regional internet service providers commonly use Dhcp. Most residential network routers receive a globally unique IP address within their provider network. Within a local network, Dhcp assigns a local IP address to devices connected on the local network. When a computer or other networked device connects to a network, the Dhcp client software sends a broadcast query requesting necessary information. Any Dhcp server on the network may service the request. The Dtp Server manages a pool of IP addresses and information about client configuration parameters such as default gateway, domain name servers, and time servers, that kind of thing. On receiving the request, the server may respond with a specific information, a bit of information for each client, as previously configured by the administrator, or with a specific address and any other information valid for the entire network and for the time period for which the allocation, or the lease as it's called, is valid. A client typically queries for this information immediately after booting and periodically thereafter before the expiration of the information. When a Dhcp client refreshes an assignment, it initially requests the same parameter values, but the Dhcp server may assign a new address based on the assignment policies set by administrators. On larger networks that consist of multiple links, a single Dhcp server may service the entire network when aided by a Dhcp relay agent, which will be located on the interconnecting routers. Such agents rely on messages between Dhcp clients and Dhcp servers located on different subnets. So depending on the implementation, Dtp servers may have 3 different methods of allocating a IP address. They could give it a dynamic allocation. A network administrator reserves a range of IP addresses for Dhcp, and each Dhcp client on the LAN is configured to request an IP address from the Dhcp server during network initialization. The request and grant process uses a lease concept with controllable time periods, allowing Dhcp servers to reclaim and then reallocate IP addresses that are not renewed. Those of you who are au fait with Linux and you've used Linux routers before and Linux firewalls, when you look in your dhcp.conf or dhcpd.conf rather, at the very bottom you'll often see a list of reserved IP addresses. Those are the static addresses that we're talking about here. You then have automatic allocation. The Dtp server permanently assigns an IP address to a requesting client from the range defined by the administrator. This is like dynamic allocation, but the Dtp server keeps a table of past IP addresses assigned so that it can preferentially assign to a client the same IP address that the clients previously had, which is very handy. Then you have manual allocation. Commonly called static allocation or a static IP address, the Dtp server allocates an IP address based on a pre-configuration mapping to each client's MAC address. This feature is variously called static DHCP assignment by DDWRT, fixed address by the DTPD documentation, and address reservation by Netgear, a DTP reservation or static DHCP by Cisco and Linksys, and IP address reservation or MAC IP address binding by various other router manufacturers. So this is the process in which a client requests access to a server. You have the Dtp Discovery. The client broadcasts a message on the network using the destination address of 255.255.255.255 or the specific subnet broadcast address. A DTP client may also request its last known IP address. If the client remains connected to the same network, then the server may grant the request. Otherwise, it depends whether the server is set up to authorize or not. As an authoritative server denies the request, causing the client to issue a new request, a non-authoritative server simply ignores the request, leading to an implementation-dependent timeout for the client to expire the request and ask for a new address. Then you have the Dtp Offer. When a DTP server receives the Dtp Discover message from the client, which is an IP address lease request, the server reserves an IP address for the client and makes a lease offer by sending a Dtp Offer message to the client. This particular message contains the client's MAC address, the IP address that the server is offering, the subnet mask, the lease duration, and the IP address of the DTP server making the offer. The server determines the configuration based on the client's hardware address as specified in the CH-ADDR or change address, the client hardware address field. Here the server of say 192.168.1.1 specifies the client's IP address in the your address field. You then have the Dtp request. In response to the Dtp offer, the client replies with a Dtp request, broadcasting to the server requesting the offered address. A client can receive Dtp offers from multiple servers, but it will accept only one Dtp offer based on required server identification options in the request and broadcasting messages. Servers are informed whose offer the client has accepted. When other DHCP servers receive this message, they withdraw any offers that they might have made to the client and return the offered address into the pool of available addresses for somebody else. And then down here at the bottom, as time goes on, you have the acknowledgement eventually. When a DHCP server receives the Dtp request messages from the client, the configuration process enters its final stage. The acknowledgement phase involves sending a DHCP ACK or acknowledgement packet to the client. This packet includes the lease duration and any other configuration information that the client might have requested. At this point in time, the IP configuration process is pretty much complete. The process expects the DTP client to configure its network interface with the negotiated parameters. After the client obtains an IP, it should probe the newly received address, such as an ARP, to prevent address conflicts caused by overlapping address pools of DHCP servers. So the first steps of enabling DHCP on an iOS router is to do a configure terminal and service DHCP, and then the next step is to create a DHCP pool that defines the network of IP addresses that will be given to the clients. So if you note here, we've got netpool is the name of the DHCP IP pool that we're creating, and this tells the router to issue IP addresses for the network 192.168.1.0, which translates to the range 192.168.1.1. 192.168.1.254 would be the end range, and you've got to exclude the IP address that you want later on. So then you can define the DHCP parameters that will be given to each client. These include the default gateway, which they call it the default router, the DNS servers, the domain name lease period in days, and the domain name and lease parameters are mandatory. By default, the lease time for an IP address is 24 hours. However, you can specify any time range you need. For example, if you need to set the release time for 4 hours and 30 minutes, you could use release for here any amount of minutes. You could just put the amount of minutes instead of hours. That's simple.